For today, we are going to discuss simplifying rational expressions. When we say fraction, it is a rational number written in a form a over b, where b should not be equal to 0. In a over b, a is our numerator and b is the denominator. You have to take note that fraction is in its simplest form when the GCF of its numerator and denominator is 1. Let's try to simplify 5 over 20. The greatest common factor of 5 and 20 is 5. So we divide 5 by 5 and that is equal to 1. We divide 20 by 5 and it is equal to 4. So the simplified form of 5 over 20 is 1 over 4. Let's proceed to our next example. 8 over 18. The greatest common factor of 8 and 18 is 2. So 8 divided by 2 is equal to 4. 18 divided by 2 is equal to 9. So the simplified form of 8 over 18 is 4 over 9. Another, 4 over 8. The greatest common factor or GCF of 4 and 8 is 2. So 4 divided by 2 is equal to 1. 8 divided by 2 is equal to 2. So the simplified form of our fraction 4 over 8 is 1/2. For our last example, we have 18 over 24. The greatest common factor of 18 and 24 is 6. So 18 divided by 6 is equal to 3. 24 divided by 6 is equal to 4. So the simplified form of 18 over 24 is 3 over 4. When we say rational expression, it is an algebraic expression of the form a over b, where a and b are polynomials and b should not be equal to 0. Now let's have a recap on identifying polynomials. X raised to negative 2. This given expression is not a polynomial. Take note that the variable should not have a negative exponent for us to say that it is a polynomial. For our next example, we have 3 over x. This expression is not a polynomial. Take note that the denominator should not have a variable. Next example, x raised to 4 over 5. This expression is not a polynomial. Take note that the variable should not have a fractional exponent for us to say that it is a polynomial. For our last example, we have the cube root of x raised to 5. So the given is a radical expression. This expression is not a polynomial. Take note that the exponent of the variable should be divisible by the index for us to say that the given expression is a polynomial. This time, let's try to identify if the given expression is rational or not. For our first example, we have 3q. If we are to write that in the form a over b, the numerator is 3q and the denominator is 1. So this given expression is rational. For our second example, we have 2x plus 1 all over the difference of x squared and 3. Observe your numerator. We need to identify if 2x plus 1 is a polynomial or not. And the answer is, it is a polynomial. Now we proceed to our denominator, x squared minus 3. Again, we need to identify if this is a polynomial or not. And the answer is, it is a polynomial. We can therefore say that the given expression is a rational expression. For our third example, we have x raised to negative 1 all over the sum of x and 2. Our numerator x raised to negative 1 is not a polynomial, while our denominator, which is x plus 2, is a polynomial. Since our numerator is not a polynomial, we can now conclude that the given expression is not a rational expression. For our last example, we have x minus 6 all over x squared plus x raised to 1/3 plus 2. Our numerator is a polynomial. Our denominator is not a polynomial. Therefore, this given expression is not a rational expression. When we say simplifying rational expression, it is modifying a rational expression to a simpler form. Take note that a rational expression is said to be in its simplest form when its numerator and denominator have no common factors other than 1. To simplify rational expression, you need to identify if the numerator and the denominator are factorable. If they are factorable, then you need to get their factors. After that, you divide out or cancel any common factor. Now let's try to simplify the following rational expressions. For our first example, we have 3m raised to 5 all over m raised to 7. Our numerator is a monomial, and our denominator is also a monomial. So all we need to do now is to cancel or divide out any common factor. We can cancel m raised to 5 and m raised to 7. M raised to 5 becomes 1, and m raised to 7 becomes m squared. What remains now in our numerator is 3 times 1, while in our denominator, we have m squared. So 3 times 1 is equal to 3 all over m squared. That is a simplified form of our 3m raised to 5 all over m raised to 7. For our second example, we have m squared minus 11m plus 18 all over m squared plus 2m minus 8. Observe our numerator. M squared minus 11m plus 18 is factorable. And the type of factoring is factoring quadratic trinomial where a is equal to 1. The factors of our numerator are m minus 2 and m minus 9. Now let's proceed to our denominator. M squared plus 2m minus 8 is also factorable. The type of factoring is factoring quadratic trinomial where a is equal to 1. And its factors are m minus 2 and m plus 4. Now we are ready to cancel or divide out our common factors. So we can cancel m minus 2. The simplified form now of the given rational expression is m minus 9 all over m plus 4. For our third example, we have m squared minus 27 plus 6m all over m squared minus 81. We need to rewrite our numerator to its standard form. So that will now become m squared plus 6m minus 27. Observe your numerator. M squared plus 6m minus 27 is factorable. The type of factoring is factoring quadratic trinomial where a is equal to 1. Its factors are m plus 9 and m minus 3. Let's proceed to our denominator. M squared minus 81 is factorable. The type of factoring is factoring the difference of two squares. Its factors are m minus 9 and m plus 9. Now we can already divide out or cancel our common factors. We cancel m plus 9. So the simplified form now of the given rational expression is m minus 3 all over m minus 9. For our fourth example, we have m cubed minus m squared minus 42m all over 2m squared minus 20m plus 42. Our numerator is factorable. We can use common monomial factor. Our common monomial factor is m. The other factor is m squared minus m minus 42. The other factor can still be factored. We can use factoring quadratic trinomial where a is equal to 1. So the complete factors now are m, m plus 6, and m minus 7. Now let's proceed to our denominator. 2m squared minus 20m plus 42 is factorable. We can also use common monomial factor. And the common monomial factor is 2. The other factor is m squared minus 10m plus 21. M squared minus 10m plus 21 is still factorable. We can use factoring quadratic trinomial where a is equal to 1. So the complete factors of our denominator are 2, m minus 7, and m minus 3. Now we are ready to cancel or divide out our common factors. And notice, what we can cancel here are your m minus 7. The remaining factors will now be multiplied. So m times m is equal to m squared. M times 6 is equal to 6m. That is for our numerator. For our denominator, we have 2 times m, which is equal to 2m. And 2 times negative 3 is equal to negative 6. So the simplified form of the given rational expression is m squared plus 6m all over 2m minus 6. For our last example, we have 64m raised to 6 minus 8 all over 4m squared minus 2. 64m raised to 6 minus 8 is factorable. We can use common monomial factor. The common monomial factor is 8, and the other factor is 8m raised to 6 minus 1. The other factor is still factorable. We can use factoring the difference of two cubes. So the complete factors of our numerator are 8, 2m squared minus 1, and 4m raised to 4 plus 2m plus 1. Let's proceed to our denominator. 4m squared minus 2 is factorable. We can also use common monomial factor. The common monomial factor is 2, and the other factor is 2m squared minus 1. We simply copy 2 and 2m squared minus 1. Now we are ready to cancel or divide out our common factors. 8 and 2 can be cancelled. They are both divisible by 2. So 8 becomes 4 and 2 becomes 1. We can also cancel 2m squared minus 1. What remains in our numerator are 4 and 4m raised to 4 plus 2m plus 1, while in our denominator we have 1. Now let's distribute 4 to our trinomial. 4 times 4m raised to 4 is equal to 16m raised to 4. 4 times 2m is equal to positive 8m. 4 times 1 is equal to positive 4. So the simplified form of our rational expression is 16m raised to 4 plus 8m plus 4. I know that some are still confused on this. 1 over 2x remains to be 1 over 2x, while 2x over 1 becomes 2x. Take note on this. If the remaining term on the numerator is 1, then you should copy it in its simplest form. If the remaining term on the denominator is 1, then you may no longer write it in its simplest form.